Hello
Hello,
everybody.
everybody.
Okay. Hello everybody. I hope I'm audible. Am I audible? Just maybe
Yes, yes,
drop me a
yes.
thumbs up.
You are able.
Yes. Okay. All right. Thank you so much. So we will start. Others might join, might take a little longer for them to join. I don't really know, but then we will start. Okay. They can then follow up by the time we introduce and things like that happens. All right. So my name is Diksha. My name is Diksha Karapurkar. I have been freelancing these courses since December. Some of you might have been connected to me ever since December. We often organize some open sessions which are open to all the GIS community members, as well as those who might be interested, and some GIS community member might have shared it with them, or that they have come across us over LinkedIn. So these are the two platforms over which these open session notifications usually are sent. So my name is Diksha Karapurkar. Today it might feel that I am heading this particular talk, but then it is basically for you all to ask you questions. So we will keep it 50-50%, wherein within first 30 minutes I will try to finish or wind up whatever I have to tell you, the basic information about it, and then we will move on to your questions. Some questions might remain unanswered, but I suggest you to put up your questions, type them out within the spreadsheet that is shared within our group. So keep that in mind. Let's move ahead. So the topic that we are discussing today, or that so far uh, that we came across, that many of us within the GIS community member were facing troubles when it was essentially to look out for a kind of satellite data, and for which date exactly, or for which particular season, if you are trying to go for a temporal change kind of study, then which data should we be selecting. So these were the problems that we were facing. We will try to address them in today's open session, and then your specific questions, definitely those are more important. So how to select the right satellite data for any kind of remote sensing studies, that is what we are discussing today. We will straight head into our discussion. We will straight head into our discussion. So why satellite data selection really matters? That is what we will discuss first. I am assuming that we know what is remote sensing, and how satellite data is used for what are the different applications that we use it for. So these are the basics that I intend you to already know, and that you already have a question, that is how to select the right data. So that question we will try to address. So why satellite data selection matters? Because essentially that is the one that is carrying all our information. Any information that we are trying to extract from the environment is lying within satellite data. So choosing the right type of satellite data, and also considering the temporal variations, seasonal variations, is also important when we are selecting these satellite data for ultimately our study and to answer our questions, right? Or to fill in the research gap. So, why satellite data selection matters? First point, influences accuracy and relevance of analysis. So, what kind of study we are doing? A relevant satellite data that will be able to answer this question has to be chosen, and then accuracy of this data also matters, right? So, the accuracy of this particular data also matters. Now, different satellites serve different applications. There are different types of satellites that you see on the screen right now. Meteorological satellites are there, oceanographic satellites are there. There are also space stations that have various other purposes, experimentation purposes within space. There are also biosatellites, communication satellites, reconnaissance satellites, and many different types. Navigation satellites are also there. Different types of optical sensors they are carrying. They are carrying different SAR sensors, or they are carrying microwave sensors. So which exactly which type of data exactly we are looking for, that will depend upon what is our problem. So what is exactly our objective? We have to have our objectives very clearly stated, wherein we know that yes, this is the problem that I'm trying to sort out, and only then you will be able to dwell into what kind of satellite data will I require. So different satellites will serve different applications. If you're trying to use a terrestrial observation satellite for studying oceanographic characters, then definitely that is not going to serve, right? So you have to identify which kind of data will answer my query. Data types impact spatial, spectral, and temporal resolution as well. So we have to consider these three aspects as well of that satellite data, upon which we will be able to then narrow down further as to which data we require. We have to talk about what is the spatial resolution that we require if we are trying to study a very micro region, a very small region, maybe like that of an estuary, then we have to go for a higher resolution data. However, let's say if we are trying to study a large region, then we can go for a coarser resolution. The temporal resolution also matters. We will definitely further look around for what these spectral, spatial, and temporal resolutions are. So these are the basic parameters to be considered. Spatial resolution, uh, how intricately or how closely a particular satellite is able to take information or sense information from the feature that we are observing. If you are trying to study something as small as, let's say, an agricultural field, then you definitely require higher resolution data. But then if you are trying to study, let's say, a vast area like that of an ocean, then definitely some lower resolution will also be sufficient for you. Temporal resolution: how often we want to observe a particular change within the feature. For example, if we want to observe what is the growth what is the growth rate of a particular crop, then we might require a very intricate and closely spaced data at maybe every second day, right? So the repetitivity is high. So we know that how what is the growth of a particular crop. But a low temporal resolution means on day 0 I have one image, and day 14 I have one imagery. So in between data I am missing. So the temporal resolution also matters. Spectral bands: how many spectral bands or how many samples of data have been collected by a particular satellite, that also matters within that electromagnetic spectrum. Radiometric resolution: what is the bandwidth of receiving a signal? Let's say if the bandwidth is high, that means what? We are receiving more information within a specific band. But then if the bandwidth is narrow, then we are collecting information within that very narrow stretch of spectral band. So that also matters. What is the width of that satellite image, swath width? How broad the region is from where we are collecting the data? That also matters. Revisit frequency is again same as temporal resolution. Whether the data is available or not, whether we have required investments or capital to purchase the data, or whether we have to look out for freely available data, that is also a big constraint when it comes to selecting data sets. So once all this is in place, you will see some here a high spatial resolution, whereas as we go towards low spatial resolution, less of complexities within the terrain is visible. Within high spatial resolution, you can see even the cars that are parked over here. Okay, so that is about spatial resolution. It's about the pixel size. Smaller is the pixel size, better is the complexity that is reflecting within a satellite data. Then this is about spectral bands. So if you have multispectral bands means you have multispectral bands means you have multiple bands that are stretching across or that are sampling the electromagnetic spectrum at a very distinct space. But then hyperspectral means there are very conjugate, closely spaced sensor bands. sensors or bands that are collecting information from a region over a wide range of electromagnetic spectrum. Then we also have RGB. At times we may also have maybe just three bands. For example, LEAS 4, which is the ISRO NRSC disseminated data. It has only three bands: band 2, 3, 4. That is, it has green, red, and near infrared. So that will come over here. Then multispectral bands. For example, Landsat has around 11 bands stretching all the way from deep blue to shortwave infrared and even thermal. So that will come into multispectral. And there are also hyperspectral data sets like that of Prisma, then or Hyperion. So coming back here, so the types of satellite sensors. We have optical sensors like Landsat or Sentinel-2, which essentially works within that VIBGYOR range, which is perceived by human eyes. Then we have radar sensor, which is essentially star data. Sentinel-1 or Reset are the satellites that will give you these radar sensors. There's just one picture about this radar. You have also have radar sensors on your cars. It tells you how far the obstacle is and what is the distance to this obstacle from your sensors. So it talks about the digital elevation model again. Next is thermal sensor. It senses the temperature present within a body, may it be forest, may it be barren land, may it be urban land, or may it be ocean. So, sensing temperature fluctuations, this is what helps. Modis Aqua and Terra are the two products that we get, one for observing the ocean, another for observing the terrestrial environment. And then we have hyperspectral sensors, which have very conjugate bands like that of Hyperion or Prisma. Uh, Moving on, so that is about thermal sensors. Now, coming back to the question, if we have discussed what are the different sensors that are available, we will now discuss how to define our research objective. Once we have a clearly defined research objective, we are in a position to select the accurate data set that we require, or the accurate or the most feasible or the most least cost or sorry most cost effective or the most time efficient kind of satellite data we require. We have to define the research objective first. There are several objectives within which maybe most of us will be able to punch in our specific research gap. One is land use land cover. Many times we have to do land use land cover, whether we are studying coastal environment or we are studying urban environment or we are studying rural kind of environment or any kind of habitat that we are studying. We essentially relate um, our variations within our area with that of land is land cover. It has influence to each and every kind of change that is ongoing within our surrounding that we are studying. Next is vegetation monitoring. We have to know how often our vegetation regrows or to what extent it is being degraded, what are the different reasons because of which it is degraded, and so on. Okay. Then hydrological studies, we want to study water level, sea level changes, so water levels within maybe a huge pond like that of maybe um, backwaters of Kerala or things like that, those areas which are along the coastal plains and are very vulnerable to sea level rise. So that is where this comes into picture. Wetlands are also there. Urban studies, if you want to study urban sprawl or urban heat island or things like that, expansion of urban areas, that is urban sprawl. So these are the other kind of studies. And then disaster mapping. There are different types of disasters, like landslide is there. There is natural disasters essentially we are talking about, and also maybe anthropogenic disasters. So everything comes into picture over here. So disaster mapping, like that of maybe landslide mapping or vulnerability assessment. Many of you are coming from that particular course. Then flood, forest fires, and others. So these also come into picture. Now, What are the requirements if we will try to relate these objectives to that of the kind of satellite data that we have to go for. These are the requirements. Let's say if we are trying to study urban mapping, if you are trying to study at what rate, let's say, urban areas are expanding, urban sprawl is ongoing. Have I been disconnected? Can you see my slide?
Yes, yes. Visible.
Yes. Okay. Yes. So at what rate the urban regions are expanding, or at what rate what are the fluctuations associated with urban heat islands and things like that, or what is the confusion matrix, or what we say, what kind of area is getting converted into another kind of area. If that is our aim, then we have to go for a 10 meter to 30 meter resolution data. The ones which are readily available without any cost, Sentinel-2, which gives you 10-meter resolution data, and then Landsat, which gives you 30-meter resolution data. Essentially, I'm talking about Landsat 7, 8, and then now the recent one, that is 9. Whereas if you are studying agricultural areas, it is a small region and you require 10-meter or below 10-meter resolution. That is a higher resolution. So you can go for Sentinel-2 or PlanetScope. PlanetScope, as you know, it is it's not a free data. You have to provide some cost for purchasing it. You have to purchase it. Then forest cover. If you're trying to study forest cover, 30-meter resolution data, that is Landsat, wonderful, and 10-meter resolution Sentinel-2. These are the ones which are mostly used for these kind of studies, and we are definitely discussing something that is most commonly being discussed. So you might find yourself dwelling between one or two and things like that. So identify yourself which objectives you are actually yielding to. Okay. Then next, wetland monitoring, 10 to 30 meter. Wetlands are very small regions, so you have to have higher resolution data. You can go for SAR kind of data, essentially, because if your area is very close to, let's say, equator, then you have have it mostly or most often covered by covered by cloud. So what you have to do is you have to look out for such a data which can penetrate to the clouds, and SAR data, that is Sentinel-1 data, is wonderful if you are using that 10 to 30-meter resolution. And then wetlands are associated with these optical components, in the sense those which are very nicely observed between these Vibgyor colors, no visible spectrum, like vegetation is there, there is water, there could also be some aquaculture activities ongoing and things like that. So that becomes more observable using these optical sensors. When we talk about optical sensors, we are again talking about Sentinel or Landsat, which are free, and now again you can talk about LIS4 as well, that is also freely available now, though it doesn't have a star kind of data, but very well you can work within red, green, and near infrared. Then disaster response, we have to have a higher temporal resolution for this. That is, if we are trying to study the response to a disaster of a region, to maybe what extent or how quickly, what was the rate at which this activities, maybe building road and things like that, progress, then you have to have a daily visit. You cannot have a revisit time of 16 days like how Landsat gives you. So you have to have frequent visits. So accordingly, you have to find the data, and that includes again MODIS and Sentinel. MODIS every 2 days or even one day. So you have to find high temporal resolution data. That means repeated a higher frequency of revisit. We can either I will be sharing this particular PPT with you, so you can go through this. It talks about a comparison of the commonly used satellite data. So you have satellite first, and then the spatial resolution of it, then temporal resolution, whether they are multispectral or hyperspectral, or what kind of it is, RGB, and whether it is free or not. PlanetScope is the only one which is not free. It has a very high resolution of 3 to 5. and it's an RGB plus NIR, like that of your Landsat, which has near infrared as well as red, green, blue. In fact, one deep blue and one blue band. Okay. Then moving on, where do we download this data from? I will be giving this PPT to you, so you will be able to find out which data exactly you want to go for, and then these are the platforms from where we can download them. Um, Google Earth Engine is the most popular one, and these days it is the one that has taken over, not keeping a necessity to download any data set. You need not really download any data set. You just need to download your end products. You can call for the cloud stored products, satellite data, and then process them, and then directly go for downloading the products that you have generated. So that is one. From Bhuvan, you can download all the Indian satellite data, that is ISRO NRSC data portal. NOAA class for weather and ocean data, USGS Earth Explorer for Landsat, Esther, and many others are also there. You can also access Earth data. That is also another platform, a very widely used one. And Copernicus Open Data Hub, that is to download all your ESA data, that is European Space Agency data. Moving on. Best practices for satellite selection. There are four. I would say four right now because many of you will yield a lot of information from these four, and then we can discuss the others. Match resolution to scale of study. You have to know what is the spatial resolution of your data set and at what scale you can map or you can report your findings. Let's say if you are using a satellite data like that of LEAS 4, then you have to map your parameters that you are trying to at a scale of 1 is to 6,000, because if you go further zoom in into this particular product, you will see that the pixels start blurring out, and that is where human error comes into picture. So you have to work at such a zoom level or such a scale rather, more technically speaking, wherein the pixels are not breaking out, or that pixelated kind of view of the satellite image is has not arrived. So you have to work at that particular scale. If you have not understood this, do let me know and we will talk a little more about it. Then consider atmospheric conditions. We have to consider whether we are studying clouds or whether we are studying the planet surface underneath. So the cloud cover also comes into picture. Then combine at times, what you can do is you can combine your optical sensor data with that of synthetic aperture radar for better insights into the study, because often these optical sensors suffer with optical or spectral sensors, they suffer with cloud cover. Once they are covered by cloud, whatever information that lies underneath will go undetected or will go waste. So you have to work with SAR data because they can penetrate the cloud cover. Then you have to always check for the metadata. You have to check for what is the acquisition date, and at what time that particular image was captured, because often you want to also associate your observations with that of tidal data, right? So you have to know at what time, at what local time the satellite imagery was captured, what and the other data that is associated with it, that is what is sun elevation, then what was the cloud cover at that particular time, what is the quality of the data, and things like that. What is the resolution of each band, and so on. That often we talk about studying a particular aspect of the region over a long period. Let's say this particular image talks about Landsat data, which has been available ever since July 1972, and then there's a series of these Landsat satellites that kept on making an overlap with that of the previous data set, right? So let's say I'm trying to study coastal environment wherein I'm trying to see how the shoreline migrated back in past all the way until 1972. So what I cannot do is I cannot take a 2024 data, let's say I cannot take a 2025 data and directly compare it with 1972 data. Why I cannot do it is essentially because Landsat 1 has a resolution of 60 meter, 58 meter, I believe, and then Landsat 9, the recent one, has a resolution of 30 meters. So how can we compare a 30-meter resolution data with that of 60-meter resolution data? A lot of human error as well as the scale of our observations will also change, isn't it? Now, in this scenario, the best approach is going to be wherein you collect data set, wherein you collect information in an overlapping manner, in the sense that, let's say, Lancet 1 has operated between 1972 to 1978, and then it was taken over by Lancet 2, wherein the continuity was also practiced between 1975 and then 83. So what I will do, I will take an imagery from July 1972. Let's say I have it, okay, very unbelievable, but let's say that in July 1972 I have a satellite imagery, and then I will take yet another that is taken in 1972. Okay, we will talk about the seasonal component also later. So I will take yet another which was taken in 1978. Okay, so I have a gap of around 6 years over here, and then I have to further go ahead in time, isn't it? So what I will do, I will yet again take a satellite imagery of 1972 from Landsat 2, from 1978 of Landsat 2, and then I will move ahead. So accordingly, what do I have? I have a comparison between two Landsat 2 products, which have a gap of some temporal gap is there, and then I also have Landsat 1 data. I am comparing Landsat 1 data to Landsat 1 data, and then Landsat 2 data to Landsat 2 data, and then again I am also comparing my Landsat 1 data, that is the most recent Landsat 1 data, and with that of the Landsat 2 data, which is the most oldest one. In this way, what I am getting to know, I'm getting to know what is the error that I am expecting. What is the error that I get when I am comparing my Landsat 1 data with that of the Landsat 2 data. So you have to have a sufficient overlap. The other way of doing it is also wherein you take 2 years, for example, just see here carefully, okay? 1976 data I can get for Landsat 1, as well as 1978 data I can get for Lancet 1. Then again, the same, that is 1975 imagery I can get for Lancet 2, as well as 1978 also I can get for Lancet 2. So I try to compare both these results and see where I am, what is the, regression, what is the regression within these two observations. And then I correlate this with my other sets of data, over which I then distribute my error, or that I ensure that I don't consider that much of error, okay, or that uncertainty within this data can be provided. And likewise, you can then um, compute the changes in coastal shoreline migration for over a large data set. Now, if you feel that I have not framed it well, just feel free to ask me that question again. Okay. Then you can also combine two data sets. So here, this is a methodology. I don't know where I have taken this from. I will send you the source of it as well. This is wherein optical data set as well as the SAR data set, that is synthetic aperture radar, has been merged together in a gradient based fusion such that the fused image then can be used for classification. So this gives you better understanding wherein you are using two different types of sensors. So this gives you a much better understanding of what is the physical or chemical character of the feature that you are studying. May it be agricultural field, may it be water body, may it be any other kind of land use land cover. So we will, I will stop over here so that we can take over onto a discussion kind of session. And yes, we will call for questions.
Hi Diksha, I had a couple of questions. Am I audible?
Amit, yes, yes, audible.
Yeah, yeah. First thing is, I mean, practically, I also found it's more of a comment and a question also. When working with the satellite data, I also found, the capabilities of my, the systems processing capabilities also matter a lot because I had earlier taken high resolution data and my system would take a lot of time or hang or something like that would happen. So then, when I started with much coarser data, it is much better, and maybe that is one consideration we should have. I mean, if you are not working on some high-end systems and working at home, that is one. Second question was about this synthetic aperture SAR data, right? So, uh, how does it actually add to this? I mean, if we take it along with what complementarity does it give to the other satellite processing that we do? I wanted to understand that. Thanks.
Yes. So synthetic aperture radar is essentially going to help us in studying the fluctuations in topography that we see. Let's say if we are studying a region which is often subjected to earthquakes or such mass wastage processes like earthquakes or maybe land subsidence, then we can use the synthetic aperture radar. It also has a high temporal frequency. For example, if we talk about Sentinel 1, which is also a SAR data 1, we can also study the fluctuations in water level. So that is also possible. That is another application of the SAR data. Besides this, our data also penetrates through the cloud cover. Now, as it penetrates, is able to penetrate through the cloud cover, it can observe the features lying on the ground. Whereas, if we talk about optical, that is VIBGYOR, RGB kind of sensors, then what they do is that the moment this light incidents upon cloud cover, then it will be reflected back. So it doesn't penetrate through the cloud, because of which our observations are also futile, or the data consideration also goes futile. I hope that answered. Amit, you have any follow-up questions?
No, no, thank you. That makes sense.
Yes. Okay. Yes.
No, I actually
We'll
have
call
one
for
question, follow-up question. Can I go ahead?
yes, 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 yes.
Okay, so right now what we do is for optical data, is it preferable for India at least? Is it preferable to use SAR data, and use SAR data for the periods that we want, or is it preferable to just find other data which has minimal cloud cover around the times that we are looking for? Which one is better?
Okay, uh, that question will be answered to you once you find your objective. If you can tell us a little bit about the objective, no, what kind of study you are doing, then maybe we
Yeah.
will be able to answer
So,
that.
so I was looking at data pre-monsoon data and post-monsoon data also. Data around the harvest times, Kharif and Rabi harvest times.
Yes, so there definitely you will be using optical sensor data, spectral bands, that is RGB and near infrared, shortwave infrared. This is the kind of data that you should look out for.
Okay.
Thermal also comes into picture. Thermal as well comes into picture. Yes, dear, somebody has raised their hands, but I'm not able to read your name. I'm so sorry. You can ask your questions.
Hello.
Yes. Hello.
Am I audible?
Yes. Yes, dear. You are audible. You are audible.
Okay. My name is Gopika. So I actually wanted to ask a question. In the case of hydrological studies, what kind of data? I have seen data regarding sea surface temperature, and nutrient monitoring is done from satellite data. And can you please explain what are the other parameters related to hydrological studies that are available through satellite data?
Yeah. Did you mention atrium anomalies? Mapping atrium
No,
anomalies within
S,
water.
no, nutrient monitoring and SST.
Okay. All right. Yes. Got it. So, I don't know to what level I should be answering it. For example, sea surface temperature, you can definitely study using Landsat. However, you will have to correlate it with your in situ observations as well, and then find what is the regression that you see, and then take it forward. But if you are talking about advanced level SST, then you have to fall back to Modis Aqua. Modis Aqua has been used for a number of purposes for studying ocean parameters, like chemical parameters as well as physical parameters. So I would suggest Modis Aqua. What are the
Okay, so
different parameters that can be
is the
studied?
data freely available?
Yes, Modis Aqua is
Sorry.
freely available. In fact, yes, Modis Aqua is freely available. In fact, you can also now use OceanSat data, which has also been made freely available. This OceanSat 1, 2, as well as 3. Or OceanSat, which is an ISRO product, has a higher resolution, but of around 360 meters as compared to that of Modis, which has a way coarser resolution of around 1 kilometer. So, but the problem with OceanSat that I personally found, being an Indian, I'm so sorry I'm mentioning this, but then the sensor seems to have not been very well calibrated. Whereas when it comes to Modis, the data is very well calibrated. There are a number of algorithms available based on the kind of product that you want to derive, whether it is chlorophyll alpha or whether it is concentration of carbon dioxide and whatnot. So everywhere, suspended sediment and yellow substance, literally everything you can extract from the readily available algorithms. That's not
Okay,
the
so
case with ocean set.
yeah, thank you. You can continue.
Yeah, yes. So that's it. You have any follow-up questions, my dear?
Yes, ma'am. Actually, one more doubt. So I have seen papers that has been written about pollutant monitoring using satellite data. So there has been papers regarding heavy metal pollutant monitoring and all. So can I get that data from these websites as well that you mentioned?
Mm, okay, so I don't really know to what extent I will be able to guide you very well. But I will tell you this one thing. Often these heavy metals are in trace amount, because of which they might not be giving a very clear indication in the form of a satellite product. But there are proxies. There are always proxies. For example, if there is an oil spill within ocean, then that often talks about heavy metal contamination. So proxies can always be identified, and then such possibilities can be reported. So I don't really know which paper exactly you're talking about. If you wish to, you can feel free to share it with me, and then I might come back to you.
Okay, ma'am. Okay.
Yes, I hope I was understandable. No, very nice said. It
Yes.
might not really be the heavy metals that could be identified from uh, remotely sensed data, unless and until it's an UAV kind of expedition, wherein drones are sent and very high resolution data, very very sophisticated kind of data is collected. I don't know to what extent that also will be able to find the concentration of heavy metals, but definitely proxies are there.
Okay, ma'am. Thank you so much.
Yes. Is there
Hello, am I audible?
yes,
Oh,
yes, audible.
okay. I just have few questions to ask. Okay.
Yes,
My first question is like if I were to, I mean, let me put it this way. It's related. My question is related to coastal areas, specifically coral reef. Okay. If my
okay.
yes, yes,
Yes. I think you reached out to me over LinkedIn, right?
yes, yes. So,
Yes.
like, if I were to collect the data of coral reef using satellite images over a specific area of interest, so that particular area of interest is a very small island, if I were to say, a very small island. So, is there any data set available for me to, like, using satellite to extract the benthic zone, I mean, benthic habitat, geomorphic zonation, and all this? Like so far, what I have known is what I have known is I only know one data set available is LN Coral Atlas. Yes, that's all I know. So is there any other available data set? Or and the other question is regarding the land cover assessment. If I were to do a baseline study of a land cover assessment, there are various data set available like S3, Dynamic World, ESA, Landsat, and all this. So which data set is more preferable if I were to use for a small scale area? Oh, yeah,
Yes.
that's it.
Okay. So could I just ask you one more question so that I can maybe frame
Okay,
my answer for you? Yeah.
okay.
So I wanted to ask you how big is the island or what is the surface area, the aerial extent of this island?
For that particular island, I'm not sure about, but it's an island. It's a very small island compared to like state is very big. Yeah.
Okay.
So yeah,
Okay.
yeah. So for this case, yeah, I have
So yeah.
okay. Let me say, I have used Google Earth Engine. So I created a save file by using geometry and all these points to create that particular island, and then I export it to the Earth Engine, and then I have used it. But then I'm a bit confused, like it giving me some errors, and that's why I'm asking this question.
Okay.
Yeah.
Okay. Got it. Yes. So I will just tell you this one norm and then I
Okay.
will continue. The norm is that if we are trying to study land use land cover changes, now I will consider even coral reefs into this for now.
Okay.
Uh, yes. So if we are trying to study land use land cover changes, then we have to ensure how big is the area that we are studying and what scale we want to study it. For example, let's say if we want to study at a scale of 1 is to 20,000 and then less than that, at that fine scale, then we have to go for very high resolution data, which is essentially optical sensors, definitely PlanetScope will be wonderful because that the resolution is zero point 0.3 to 5 meter or something like that. So that's a good resolution data. There's a constellation of this data set as well. So that means you have very high temporal frequency at which the data is collected. So you know at a very minute scale as well what are the changes that are going on and at a very micro scale as in very high resolution. That is one thing. Now, when they are using, because you mentioned Coral at last, even I didn't know much about it, but thanks for reaching out earlier so that I could have made some understanding about the kind of data set and the kind of problem that you are exploring. That brings me just to say this that when we are using this Coral at last, uh, this data may not really always reflect very micro scale features. Like, for example, because especially you mentioned that the island is very small, I would say this. You are, I believe, very much interested in micro scale features or even maybe very recent coral reef changes, if there is any bleaching, where the bleaching is, and then as we know, bleaching though is rapid on a geological scale, I should say, but on a very, maybe a tidal range or something like that, that forms a very micro scale changes that we have to observe in coral reefs. Wherein again, Planetscope will be wonderful. You can go for using it. Both that is infrared as well as optical sensor data is available. So maybe pairing it with local or local some drone data or drone survey can be useful for ground truthing, I should say. I mean, overall, definitely you must have understood that I'm not very competent in speaking about it. I have not done any work in coral bleaching.
Okay.
The only thing that I have done is oil spilling.
Oil
So
spill.
oil spills in, yes, again along the Lakshadweep coral reefs. So I'm not really concentrated on coral reefs, but you can also study dissolved carbon dioxide as well. I think. Have you read anything about it? Dissolved carbon dioxide within
This
seawater. That is also dissolved carbon dioxide within
dissolve.
seawater. That is also,
Okay. Dissolve
yes. So
carbon.
carbon
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 dioxide.
dioxide.
Okay. Okay. Okay.
Yes, dissolved carbon dioxide. So, because these coral reefs are calcium carbonates,
Mm.
if you have higher carbon dioxide, dissolved carbon dioxide concentration within these surface waters, which is very unusual otherwise, then this is a good proxy for ongoing bleaching of corals.
Coral reef. Okay.
Specifically, I'm saying this. Saying this because carbon dioxide is essentially at a lower concentration or a very constant concentration within the surface seawater, because there are phytoplanktons, they are constantly taking it up. But then if you see unusually high carbon dioxide, dissolved carbon dioxide concentration within this water, then yes, definitely it is corals which are bleaching.
Thank you. Thank you.
Yes. I do know that I could not answer your question,
It's okay, ma'am. I'll
but
just try to do some research more about it. But yeah, thank you. Thank you for your answer, ma'am. Thank you.
yes, yes, yes. If I come across something in this regard, definitely I will knock up to you.
Yes, please. Yes, thank you.
Yes, yes. Okay.
Hello, ma'am.
Yes. Hello.
Ma'am, I actually had one doubt. It's first question is not regarding this presentation, but just a general doubt actually. So there are national institutes like IITM or IITs, right? So if we ask for some kind of satellite data from them, like through a request from an organization or institute or something, can we get access to? Can they get us those data that we need?
I think you are concerned about in situ data, isn't it? You're asking for in situ data or satellite data?
If there are satellite data itself, but if we need something which is of high resolution or something,
Hmm. That's
then which
really
is
a
freely
question
available.
to ponder upon. Yeah, that's really a question to ponder upon. So some 4 years back, I was working in a ISRO Respond project, and our focal person was from Space Application Center, Ahmedabad.
Okay.
So because that particular project was again managed, and we had collaboration with Space Application Center and these particular scientists, very renowned scientists, Dr. Ratish Ramakrishnan, we could request for data and sir would make it available. So I think collaboration is the answer to it. If you have a
Okay.
collaboration, wonderful, but we can build a collaboration, and all these scientists are very much interested in collaborating with young researchers, you will definitely have a positive answer for your request. I would say I won't disappoint you because that definitely is possible because you're using it for your research purpose.
Okay, ma'am. Thank you. Actually, I had one more doubt. You showed a picture of combining the optical and SAR, like for better insights. A picture regarding how we pre-process it and all. So,
Yes.
is that's just specific to this original 2B and 1A, right? Like for each input image, the process is different, right?
Yes, for fusion of two different sensor data, there is definitely different process, but more or less it goes by this method that is gradient based fusion. That is the one that we go for, which means that one of your satellite is not collecting data from a specific region, whereas the other one can penetrate and collect some information. So what this fusion process does is that it has continuous monitoring or continuous partial monitoring of for a one particular data. It catches the slope or the gradient within this penetrating data and then makes it applicable to the optical sensor. It has some known values. For example, those regions where both optical sensor as well as SAR could collect some data, and then for those regions that it doesn't have, it tries to calculate what it could be, much like a machine learning process.
Okay, ma'am. Thank you so much.
Process remains more or less same. Okay. In fact, the same process you can use for other data as well. There will be a little things that you have to be taking care about that they are not temporarily vastly spaced. For example, if you are taking one satellite data for maybe the month of April or maybe pre-monsoon, the other cannot be post-monsoon. So you have to ensure that least time gap is kept between collection of the two satellite data. That's the only thing, such that major seasonal changes have not occurred within the picture.
Okay, ma'am. Thank you.
Yes. Okay. Is there
Hello, ma'am.
anybody who? Yes. Yes, Amler.
Yes, ma'am. Yes, ma'am. Good evening, ma'am. Ma'am,
Good
I'm
evening.
just making a map. Yeah, I'm just making a map of my study area. I am studying about the carbon sequestrations, like soil carbon sequestration as well as the biomass carbon sequestrations of my study area. So it's about the area is about 2,000 acres. So, like,
Okay.
which kind of satellite image should be needed to make this map?
2000 acres. Okay. So 2000 acres, which is I think much above 100 square kilometer. Let me just find it out. 2000 acre. If you have any access, just maybe tell me how many square kilometers it will be. 2000 acres to square kilometer. Oh, that's 8 square kilometers. Okay. If your area is essentially less than 100 square kilometers, remember this norm, okay? If your area is less than 100 square kilometers, you have to go for whatever higher resolution that you can go for. If you are fine with using an RGB kind of sensor, then you have to go for LEAS 4, that is free of cost. But if you have a lot of money or significant money, then you can go for PlanetScope. Uh, that is whatever courser resolution that you can. But if you are trying to study a region which is more than 100 square kilometers, then it's much better if you go for a coarser data wherein within a pixel, whatever changes are happening, those are um, averaged out. If you are studying as sensitive of a topic as that of carbon sequestration, you must be definitely studying maybe a wetland or something like that, isn't it, Amlan? Are you studying a wetland kind of thing, coastal area, wetland, or
Uh,
something like that,
no, ma'am.
or a
It's
forest?
a hilly region, ma'am, in Uttar Pradesh. So it's a little bit of forest land as well as the barren lands as well. It's also agroforestry lands. So it's not about the coastland. Like,
Okay, 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 getting you. Uh, for a terrestrial, definitely I would always suggest you to go for Landsat if it is terrestrial. And if you want free data, you can go very easily for either Landsat if you are fine with a 30-meter resolution. But if you want a little coarser resolution but not as coarse as maybe less than a meter, then you can go for Sentinel-2 data, because that also has a 10-meter resolution
okay, ma'am.
type.
So Sentinel-2 and the Landsats.
Yes, Sentinel-2 for Corsair and Landsat for a little. Sorry, Sentinel-2 for finer and Landsat for a little coarser. Definitely.
Okay, okay, ma'am. Thank you, ma'am.
Availability of bands is also wonderful there, both in Sentinel as well as in Landsat. Availability of the, because it has it might not be hyperspectral. I have heard some of my um, advisors also calling Sentinel as hyperspectral, but then it's just about what purpose you are using them for. I would say that Sentinel is a multispectral data. Wonderful, you can go for Sentinel. Sentinel 2, very specifically.
Okay, ma'am. Thank you.
Yes. Okay. If you are studying a region which is affected by tidal fluctuations, then make sure that you note down at what time that particular image was taken and what was the corresponding tide level. Which means if you are studying coastal changes, you cannot be using one high tide image and the other low tide image. Similarly, you cannot switch between the seasons if you are comparing, unless and until your main objective is itself is to study the seasonal changes between maybe pre-monsoon and post-monsoon. What were the changes that happened? But if you are studying annual changes or decadal changes, I would always suggest you to go for checking two things: what is the tide level while the image was taken, and the other is what was the season. Make sure that you use the same season, pre-monsoon then pre-monsoon. Specifically, that week also you can look out for. Okay. Any other question? You can as well type out your questions. At times, it may so happen, no, that while we are doing this, we are going through this discussion, you might not think of the question. Later, you can frame it and put it in the same spreadsheet link that was shared um, on our group. So those questions also I will try to answer. Anybody is waiting to a question to put their question? Is there any question in the message box? No. Okay. Okay. So you may join our, yes, thank you, Azhar. You may join the GIS community group that I mentioned, where usually the notifications come for any open session. So that's a quick way. If you're not visiting LinkedIn very regularly, then you can join us using this QR code towards your um, right. And if you wish to connect to me over LinkedIn, you can scan the right hand side, sorry, left hand side QR code. Thank you so much for joining. Have a great evening. If you come up with any questions, feel free to drop them in that spreadsheet. Those will be answered. Have a great evening. See you someday around.